Welcome back to the review for the midterm, winter 23. We're looking at problem 6 here. We've got a couple of box plots, and they show the median U.S. incomes by state for 2007 and 2009. So this is population data. It's all 50 states for these 2 years. And it's asking us to estimate the following from the box plot for 2007, which is the one on the top. Okay, so it's asking us to find the minimum, which would be this value right here. And we're going to approximate that at about 38,000. And Q1 is the left side of the box. And that is about, I'm going to say that's right around 46,750. And then the median is Q2, and that's right. It's the line inside the box. Now, always in the middle, but it's inside. I'm going to estimate that at 51,250. And then Q3, I'm going to estimate at 58,000. And then the maximum, I'm going to estimate at about 68,750. Then B says, estimate the following from the box plot for 2007. So using the same data up in part A, find the range. The range, again, is the max minus the min. And so that would be 68,750 minus 38,000. So that's about 30,750. And measure the interquartile range. So the IQR is the Q3 minus the Q1. And so that's the difference between these two. It's always the bigger one minus the smaller one. Your IQR should always be positive. And this is 11,250. Describe the shape. So again, when I say describe the shape, I'm asking you to tell me if it's skewed or symmetric. And we're talking about 2007 again. And I could see either symmetric or positively skewed. This tail is a little bit longer on the right, and the median is a little bit off center. So I would accept either. D says, what percentage of the states in 2009 have a median income between 50,500 and 54,950? So 50,500 would be right here, which is the median, to 54,950, which would be here, the Q3. So that should be 25%. E says, what percentage of the states in 2009 had median incomes above 45,000? 45,000 in 2009 is Q1. So that means 25% fall below and 75% fall above is what they're asking. F says, what does the graph reveal overall about the change in the economy of America from 2007 to 2009? Explain using the graph. And I said, on average, from 2007 to 2009, the median income has decreased slightly. It doesn't look like it's been a huge decrease, but a slight decrease in the median income. Okay, that's question 6. So question 7 is with this table here. So question 7 says, there were 1,150 children total adopted in the state of Georgia in 2006, according to the Administration of Children and Families. The frequency distribution of the ages of all the children at adoption is shown in the table below. Okay. So one thing that we should know is that it's the total adopted in the year 2006. So this would be population data, because we have all of the adopted children. And it looks like we need to fill in the table. So we need to do the midpoints. Midpoints are based on these classes. So the midpoints are the lower midpoint, the lower boundaries added and then divided by 2. So the average of the lower boundaries. So this one will be 2, and then the average of 4 plus 8 divided by 2 is 12 divided by 2, or 6. And then the average of the next two would be 10. And then the average of the next two would be 14. And then notice that there's a pattern of 2, 6, 10, 14. The difference is 4. That's our width. And you can see that the width is always the same from the lower boundaries to the upper boundaries to each other. And so that helps us build the last midpoint of the last class should then be 4 away. So that should be 18. Okay. So they gave us the frequencies. So let's go through what this means. This says that there were 611 children adopted in the age group of 4 to 8 years old. And we're going to let 6 years old be the midpoint of that class. So the relative frequency is the fractional or decimal part of each of these individual class frequencies divided by the total, which should be 1150. So this is going to be 12 divided by 1150, 611 divided by 1150, 320, 161, and 46. And those simplify to the decimals of 0.010 and then 0.531. And then 0.278, 0.14. I don't have the other third decimal on that. And then this is 0.04. Let me check this. Yeah, this is an even 0.14, and that was an even 0.04. Okay. Then the cumulative frequency is accumulating the frequency column. And so it starts with the original first row, 12, and then we're accumulating as we go. So we're going to take 12 and we're going to add the next class frequency, which is 611. So 12 plus 611 equals 623. And then 623, it's a rolling total. So 623 added the next row total of 320 is 943. And then we add 161 to get 1104. And then we add 46, and we should end up with our total from all the frequencies of 1150. Then our cumulative relative frequency is based on the relative frequency. It's just accumulating. So again, we're going to start with the first one. And I went to 4 decimal places there. I didn't need to. And then we're going to add the 0.531. So we get 0.540. And then we're going to add 0.54 to the next row's relative frequency of 0.278. And we get 0.818. And then we're going to add the next row's relative frequency to get 0.958. And then lastly, we'll add the 0.04, and we get very, very close, but it's 0.998. And depending on your rounding, you should get close to 1. Getting to 1 is ideal. Okay. This says, what type of data is the variable age? And we are going to choose quantitative continuous because age is measured, and also because we're using midpoints. we have to treat this as continuous because we don't know the exact data points. We just know that 2 children fell in this age group, 6 fell in this, or I'm sorry, 12 fell in the first age group, 611 fell in the second age group, 320 fell in the third age group, and so on. Next up, we're going to find the mean and standard deviation and variance. And so we're going to go to Desmos for that. So go ahead and open up your Desmos. Okay, here's our data. Notice X3 are my midpoints of the ages that the children were adopted, and Y3 are the frequencies. To do the weighted mean, we have to take into account both columns, because the 12 means that I really have 12 people at the age of 2, and I have 611 people at the age of 6. So to find that weighted mean, I have to take the total of their products. So I have to multiply the 2 columns together and then divide by the total frequencies, which is your Y column. So the mean is 8.67. 8.671. And then the standard deviation in the variance. So I did the variance first, that's right here. And that is using that formula where we're taking the deviations right here, X3 minus, I have to hand type the mean 8.67, and I'm going to square those and then multiply by the frequency column of Y3, and totaling adds those up. And then I'm going to divide by, again, the total frequencies. So 12.203 is the variance. And then when we take the square root, and you can just copy this whole thing and then paste it right under the square root. So when you do that, that's our standard deviation, 3.49. 3.493. So I'm going to take us back to the paper so you can see what I wrote on my paper here. Okay. D says, why is the mean referred to as estimated values? And that is because they are calculated based on midpoints. We don't have raw data. And then E says, explain why it makes sense to treat this frequency distribution as a population. And that's because we have ages from every child adopted in 2006 in Georgia. So it's considered population data. Okay. While we're here, let's just do problem number 8, and then we'll wrap up this video. So it says, determine whether events A and B are independent or not. Circle the best choice. So getting a letter from an aunt, and event B is getting a bank statement in the mail. One should not affect the outcome of the other, so they should be independent events. And then the next one says, event A is buying a new shirt on sale, and event B is having money for lunch the day you buy the shirt. So I would say these are dependent, because buying a new shirt does change the likelihood of having money for lunch on that same day, depending on how expensive the shirt was. That's definitely dependent. So catch me back for some more problems from the midterm review.